Hello everyone, in this video let us solve this question. So we have 2 raised to power t is equal to t raised to power 32, and here we have to solve for the value of t in this question. So t is equal to question mark. Now to solve this, solution. So we have 2 raised to power t is equal to t raised to power 32. Now the first thing we're going to do is to eliminate this power t right here, and to do so we're going to multiply both sides with power 1 over t. So this becomes, in bracket, 2 raised to power t all raised to power 1 over t is equal to, in bracket, t raised to power 32 all raised to power 1 over t. So with this, power t right here multiplies 1 over t, following this rule that if you have a raised to power b or power of c, this equals a raised to power b times c. So applying this right here and here also, what we then have is 2 raised to power t multiplies 1, that becomes t. Then we have over t is equal to power 32 multiplies 1, this becomes t raised to power 32 all over t. Now from here, okay, what we have is this, t, we cancel t, we have 1, so 2 raised to power 1 is equal to t raised to power 32 all over t. So with this, the next thing is to eliminate power 32 right here, and to do so, we are going to multiply both sides with power 1 over 32. So in bracket, we have 2 raised to power 1, then multiplied by power 1 over 32 is equal to, in bracket, t raised to power 32 over t, then all raised to power 1 over 32. So with this, what we have is power 1 right here multiplies 1 over 32. This becomes 2 raised to power 1 over 32 is equal to t. Then power 32 multiplies 1, we have 32 all over t multiplies 32, we have 32t. Okay, so what we then have is this, that 2 raised to power 1 over 32 is equal to t. Now 32 will come to 32, we have 1 over t. So from here, we have this. Looking at the right hand side right here, you see that the base is equal to the power denominator, which is also t right here. But on the left hand side, the base right here is not equal to the power denominator, and we are going to make the base right here to equal the power denominator. And to do so, okay, we can simply solve it this way. So first, let's first factorize out power 1 from here. So this becomes 2 raised to power 1 times 1 over 32 is equal to t raised to power 1 over t. So then, applying this trick, okay, that the trick of equivalent fraction, this means that if you have 1 can be written as 2 over 2, and can also be written as 3 over 3, same thing also as 4 over 4, because they'll still give you 1, okay. So with this, you can replace 1 with 2 over 2. So this becomes 2 raised to power 1. 1 becomes 2 over 2 times 1 over 32 is equal to, here we have t raised to power 1 over t. So from here, multiplying the powers, 2 raised to power 2 times 1 is 2 over 2 times 32 is 64 is equal to t raised to power 1 over t. Then, factorizing out power 2 from here, what we have is 2 raised to power 2 times 1 over 64, right? Because 2 times 1 is 2, so is equal to t raised to power 1 over t. And then applying this rule of indices, that if you have a raised to power b times c, this equals, in bracket, a raised to power b or power of c. Applying this rule right here, what we then have is this, okay, we're going to have, in brackets, 2 raised to power 2 and all raised to power 1 over 64 is equal to t raised to power 1 over t. So with this, okay, 2 squared is equal to 4, all raised to power 1 over 64 is equal to t raised to power 1 over t. Now, at this junction, the base right here is not still equal to the power denominator right here. So we are still going to solve it further. First of all, factorize out 1 from here. This becomes 4 raised to power 1 times 1 over 64 is equal to t raised to power 1 over t. And with this, we can make use of equivalent fraction, such that instead of writing 1, we can write 1 with respect to it 2 over 2, because 2 over 2 still give us 1. So this becomes 4 raised to power 2 over 2 times 1 over 64 is equal to t raised to power 1 over t. So from here, what we have is this. We are going to multiply the powers. So 4 raised to power 2 times 1 is 2, all over 2 times 64 is 128 is equal to, we have t raised to power 1 over t. So then, factorizing out power 2 from here, what we're going to have is this. 4 raised to power 2 times 1 over 128 is equal to t raised to power 1 over t. So, applying this rule, that if you have a raised to power b times c, this equals in bracket a raised to power b all power of c. Applying this rule right here, what we are then going to have is this, that in brackets 4 raised to power 2 all raised to power 1 over 128 is equal to t raised to power 1 over t. Now from here, 4 squared is 16 all raised to power 1 over 128 is equal to t raised to power 1 over t. Now with this, if you look at this also, we notice that the base right here is not still equal to the power denominator right here, as we have on the right hand side. So we are still going to solve this further. First, factorize out 1 again from here. This becomes 16 raised to power 1 times 1 over 128 is equal to t raised to power 1 over t. Now with this, we can replace 1 with 2 over 2. This becomes 16 raised to power 2 over 2 times we have 1 over 128 is equal to t raised to power 1 over t. Now from here, we have 16 raised to power 2 times 1 is 2 over 2 times 128 is 256 is equal to, we have t raised to power 1 over t. Now from here, factorizing out 2 from here, power 2, you're going to have 16 raised to power 2 times 1 over 256 is equal to t raised to power 1 over t. Then, applying this rule, that if you have a raised to power b times c, this equals in bracket a raised to power b all power of c. Applying this rule right here, what we then have is this, in bracket 16 raised to power 2 all raised to power 1 over 256 is equal to t raised to power 1 over t. Now from here, 16 squared is equal to 256, then raised to power 1 over 256 is equal to t raised to power 1 over t. Okay, good. So with this, what we have is this. We have made the base right here to equal the power denominator right here. Same thing also in this place on the right hand side. The base here is equal to the power denominator right here. Good. So applying this rule of indices, that if you have a raised to power b is equal to a raised to power c, since the bases are equal, we can simply compare the exponents, such that we equate the powers to each other. B is equal to c. So applying this right here, okay, we are simply going to equate the powers. So we have 1 over 256 is equal to 1 over t. To then solve this, simply cross multiply. T times 1 is t is equal to 1 times 256 is 256. So with this, we have gotten the value of t as 256. But then let us confirm if truly the value of t that we got as 256 is the correct solution. Now the question is 2 raised to power t is equal to t raised to power 32. So let us check. Let's check. So the solution of t that we got, t is equal to 256. Inputting t as 256 into the equation, what we have is 2 raised to power 256 is equal to t is 256 raised to power 32. With this equal each other, question mark. Now from here, recall that 16 times 16 is equal to 256, right? So in replace of 256, we're going to bring in 16 times 16. So right here, this becomes 2 raised to power 16 times 16 is equal to 256 raised to power 32. So with this equal each other, question mark. Now from here, applying this rule of indices, that if you have a raised to power b times c, this equals in bracket a raised to power b or power of c. Applying this rule right here, this then becomes, we have it as in brackets 2 raised to power 16 all over 16, with this equal 256 raised to power 32 question mark. Now the value of 2 raised to power 16 is 65536 raised to power 16, with this equal 256 raised to power 32. Now 32 can be written as 2 times 16. Okay, so with this equal question mark. Now from here, 65536 raised to power 16 is equal to 256 squared is equal to 65536 raised to power 16. So as you can see, this means that the value of t that we got right here as 256 is the correct solution. So with this, I hope you all enjoyed the video. Don't forget to like the video, subscribe to this channel. Thanks for watching. See you in the next video. Bye.